Hello students. So today we will talk about the system of linear equation. So what is the system of linear equation and what is the solution of it? How to find the solution, and we will find the solution with the help of inverse matrix. Okay, so let's start the class. So system of the linear equation. Okay, so here I'm taking this system of linear equation given by this a1x plus b1y plus c1z equals to d1, and a2x plus b2y plus c2z equals to d2, and a3x plus b3y plus c3z equal to d3. Okay, so this is the given system of equation. Look at here, three unknowns are there and three equations are there. Now we will represent this system of this linear equation in the form of a matrix. So let's see how we will represent this system of equation in the form of matrix. So if I take this, A is just A1, B1, C1, A2, B2, C2, A3, B3, C3. That means the coefficients of X, Y, and Z. Look at that coefficient of X, A1, A2, A3, A1, A2, A3, B1, B2, B3, and C1, C2, C3. Okay, so this A is called coefficient matrix. Now X is what? This unknowns X, Y, and Z, and B is this terms, that is the constant terms, that is D1, D2, D3. Now look at that. We can write this system as in the matrix form AX equals to B. Just multiply this A with X, you will find the system, and which is equals to D. Okay, and you know, if these two matrices are equal, then how we will define this equality? That is, the first, if this A, B, C is equals to 1, 2, 3, that means what? A is 1, B is 2, and C is 3. You know how to find this equality of these two matrices. So this is the representation of the system of linear equation in the form of matrix. Now solution of it. Now you know there are two types of solutions, that is maybe the system has one or more solution or no solution. Consistent, inconsistent. So look at this matrix A. Now for finding the inverses, we are using the inverse of a matrix. For finding the inverse, two cases will arise. That is, first case is what? If A is non-singular and if A is singular. So if A is non-singular, then we can easily find the A inverse. So that time the solution of the system, this Ax equals to B, this is a given system of linear equation, just operate both sides by A inverse. So multiplying from the left A inverse into Ax and again A inverse into B. Right? Now look at that. A inverse into A is what? Identity. Right? So A inverse into A is identity. Put the identity. So identity into X, it will be X again. So X is equals to A inverse B. Okay, so we need to find the value of X, that is the unknowns X, Y, and Z. X, Y, and Z. We need to find these values, X, Y, and Z. So this is the formula for finding the unknowns, that is the X, Y, Z, or solve the linear equation whenever this A is a non-singular matrix. Okay, so this is the solution by the inverse of a matrix. This is the solution of the system of linear equation. And in that case, there is the unique solution exists. Okay, now if A is singular matrix, that means this determinant of A will be 0, or you can write determinant of A is 0. Any notation you can use. So determinant of A is 0. So that time A inverse does not exist. So in that case, what we will do, we will take this adjoint A into B. We will find the adjoint A and then we will multiply with B, and we will discuss its solution just upon this value, upon this matrix adjoint A into B. So if this adjoint A into B is non-zero, that is, if it is a zero matrix, if it is not a zero matrix, then the solution does not exist. Or we can say the system is called inconsistent. But if it is a zero matrix, the multiplication adjoint A into B is a zero matrix, then the system either consistent or inconsistent, according to as the system have either infinitely many solution or no solution. It will depend upon the system that it has infinitely many solution or no solution. Okay, so in most of the cases, A is non-singular, it's a given, and you need to find the system of you need to solve this system of this linear equation. Most of the cases are where A is non-singular. So let us solve this exercise. So the first, you need to examine that the system is consistent or not. That is, it has a solution exists or not. So let us take the first one, that is question number 1, x plus 2y is equals to 2 and 2x plus 3y is equals to 3. So this is the system. Two equations, two unknowns, equation 1 and equation 2. So firstly, represent the system in a matrix form, that is Ax equals to B, where A is the coefficient matrix, that is 1, 2, 2, 3, and x is x and y, and B is what? 2 and 3. Okay, so firstly check A is non-zero or 0. Just multiply them. 3 minus 4, that is minus 1, that is non-zero. So A inverse exists. So that means A is what? The system A is non-singular, that means A inverse exists, and the system is, that is, the system has a unique solution, that is consistent. Okay, so like that we need to solve this from 1, 2, 3, 4, 5 and 6. So next I am choosing this question number 3. So here is the system, x plus 3y equals to 5 and 2x plus 6y equals to 8. Question number 2 is your homework. Same type of question. Now look at that. So represent the system in the form of matrix. So it will be 1, 3, 2, 6. A is 1, 3, 2, 6. X is x and y. And B is 5, 8. Now look at that. The determinant of A is what? 0. 6 minus 3 2 is 6. So 6 minus 6 is 0. Now this is singular. So A is singular matrix. That means we need to check this adjoint into B. So for 2 by 2 matrix, it's very easy to find the adjoint. Just exchange the diagonal, and for the off diagonal add just minus sign. So exchange 1 and 6 and add minus to 3 and 2. This is the adjoint. Now adjoint into B. Just multiply these matrices. Now look at that. The matrix is given by 6 minus 2. That means this is non-zero. And for the non-zero case, you know that the solution does not exist. It's confirmed that the solution does not exist. But if it is 0, that 0 matrix, then we need to check further that it has infinitely many solution or no solution, which you can easily check by its coefficients. Right? You know how to check. We have already learned. So, hence the given system, write down the answer, is inconsistent. So moving to the next question. Question number 4. So the given system is x plus y plus z is 1, 2x plus 3y plus 2z equals to 2, ax plus ay plus 2az equals to 4. So first of all, write down the system in a matrix form. Ax equals to b, where a is 1, 1, 1, 2, 3, 2, a, 2a, and b is 1, 2, 4. And x is x, y, z, 3 unknowns, 3 equations. Now, you need to check the determinant of A. You can directly break the determinant and you can calculate, or you can apply the row or column operation and then you can find the value of this determinant. So here I'm using this row and column operation, such a way it will be more easier to solve. So just subtract this column, so C2 minus C1 and C3 minus C1, just do it, and it will be a upper triangular matrix, right? This 3 elements are 0, so that means the determinant value is just multiply its diagonal elements, 1 into 1 into A. So that means this is non-zero, and if this is non-zero, that means it is non-singular, that means there exists a solution, that means A inverse exists, and this is consistent. The system is consistent. So moving to the next one. So the given system, question number 5, 3x minus y minus 2z equals to 2, 2y minus z is equals to minus 1, and 3x minus 5y equals to 3. So first of all, write down the system. I'm not explaining that how we will write down the system in the form of Ax equals to B. Since A is what? Coefficient matrix. So you can easily write down the coefficient matrix. Now check the determinant. Okay. So here also I'm using this row and column operation, and ultimately the value of this determinant is 0. That means A is singular. Now if A is singular, we need to find its adjoint. So first of all, find its adjoint and then multiply the adjoint with B. Now you know how to find the adjoint, that is the cofactor, and take it transpose. For the first element, I'm just telling you, for 3, it will be 2 into 0, that is 0, minus 1 into minus 5. So there will be minus 5. Right? Look at here. Okay. So like that, you can write down the cofactors and then take it transpose. So look at that. This adjoint A into B is non-zero. If it is non-zero, then we can easily say that the system, this equation, the system of equations is inconsistent. Okay. Oh, correct this one. This will be inconsistent. No solution. So moving to the next one. Solve the system of linear equation. Question number 4, question number 7 to 14. This all questions you need to solve it. You need to solve the system of linear equation. That is, you need to find the value of x, y, and z. So first of all, 2 unknowns and 2 equation. That is the question number 7. So first of all, write down the system in the form of x equals to b. That is, A is what? 5, 2, 7, 3, and B is 4, 5. Now, find the determinant, that is 1, non-zero. So if it is non-zero, A inverse exists. So write down A is non-singular and therefore A inverse exists. Now if A inverse exists, so we can easily find this A inverse is equals to 1 upon determinant A into adjoint A. Now it is very easy to find the adjoint for 2 by 2 matrix. Just exchange the diagonal, and for the off diagonal just add minus sign. So, and dividing by 1, that will remain same. Now the solution is, the formula is x equals to A inverse B. So write down A inverse and then B and then simply multiply them. I'm not explaining the multiplication, since explaining just 2 multiply with 4, then 3 multiply with 4, then 2 multiply with 5, and then we are adding this. This is quite boring. So do this calculation and write down the answer. So x is what? X is 2 and y is minus 3. So this is the solution of the system. You can recheck the system also by using another process, that is substitution or elimination, whatever process, cross multiplication. You can recheck the answers. So moving to the next question. So here is the next question, question number 8. So first of all, write down the system. Here is also 2 unknowns, 2 equations. So 2 minus 1, 3, 4 and minus 2, 3 is B. So find A first. A is what? Determinant of A is 11, that is non-zero. So then find A inverse 1 upon determinant A into adjoint A. Now for adjoint, it's very easy to find. Okay, so this is A inverse 1 upon 11, 4, 1, minus 3, 2. Now let us find this x, that is A inverse into B. Okay, so it's very easy to solve the equations. Okay, so you can write down this 1 upon 11 outside of this matrix, or you can just take it inside also. Here I am taking this 1 upon 11 outside of it, and after multiplication A inverse B, then I am taking this 1 upon 11 inside. So that means x is minus 5 by 11 and y is 12 upon 11. So this is the answer of this system of equation. So moving to the next one, question number 11. First of all, write down the system in the form of x equals to b, and this is the system. A is 2, 1, 1, 1 minus 2 minus 1, 0, 3 minus 5. For finding the determinant, you can use this row or column operation, or you can just break down the determinant and you can easily find the value. So A is here non-zero, that is determinant A is here non-zero, 34. So we can say that A inverse exists. Now if A inverse exists, so first of all find adjoint A, that is take the cofactors and then bracket transpose. So for 1, so take this element 2, so cofactor of it, 5 into 2, 10, minus minus plus. So 10 and minus minus plus 3, 13. Look at here, 13. For 1, it will be minus 5 and minus 3. Minus 8, since this is the second element, so minus again added. So it will be 8. Okay, so like that, find the cofactors and take it transpose. So adjoint A by determinant A is the A inverse. So 1 by 34 into this adjoint A. So I'm taking 1 by 34 out of the matrix, and after calculation, after multiplying with B, I will take this inside. So next find this x, that is x is what? A inverse into B. So write down A inverse and write down B and just simply multiply them row with column, and then take this 34, 1 upon 34 inside. So value of x is 1, value of y is 1 upon 2, and z is minus 3 by 2. Okay, I'm not explaining the calculation since it's your job, so do it. So moving to the next question. Question number 14. So the system of equation is given. So write down in the form of ax equals to b. So here it is, 1 minus 1, 2, 3, 4 minus 5, 2 minus 1, 3. and B is 7 minus 5, 12. Now find A, determinant of A. So here also I am just break this determinant and finding the value. So this will be 4. There is non-zero. So that means A inverse exists. A is non-singular. A inverse exists. So now if A inverse exists, then find adjoint of A. That means cofactors of the elements and take its transpose. So again I am talking about the third one. 2. So this is 5 into 1, 5 minus 8. So look at here. This is 3 minus 3. Okay. So like that, find the cofactors and take its transpose, and then 1 upon determinant A into adjoint A. There is 1 upon 4 into this adjoint matrix. And now find this with the formula, that is X is equals to A inverse B. So write down A inverse, then B, that is 7 minus 5, 12, and just multiply, that is row with column, multiplied 1 upon 4 into this matrix. It's given by 8, 4, 12. Ultimately, there will be 2, 1, 3. That means X is what? 2, Y is 1, and Z is 3. Clear? So this is the solution of this system of linear equation. So moving to the next question. Question number 15. If A is given, find A inverse. Using A inverse, solve the system of equation. This equation is given. Now look at that equation. 2 minus 3 plus 5. 2 minus 3 plus 5. 3, 2 minus 4. 3, 2 minus 4. 1, 1 minus 2. 1, 1 minus 2. That means this is A is what? A is the coefficient matrix for this system. Right? So first of all, we need to find the A inverse for this given matrix A, and then we need to solve it. So first of all, find A inverse. For finding it, firstly we need determinant of A, which is minus 1. That means it is non-zero. That means A is non-singular and A inverse exists. So if A inverse exists, find adjoint. So write down the cofactors and take it transpose. I'm just writing down the value directly. You can solve it in rough, and you can write down directly the value of this adjoint, or you can solve it, that is writing down the cofactors and then taking its transpose. Okay, so moving to the next part, that is the inverse, that is 1 upon adjoint, 1 upon determinant A into adjoint A. So determinant A is minus 1. So just take this minus inside of this matrix. So it will be 0, 1, minus 2, 9, 20, minus 23, minus 1, 5, minus 13. Now finding the solution of this system of equation. That means you need to write down, you need to find the value of X, Y, and Z. That means you need to apply the formula, that is X is equals to A inverse B. Since we already find the A inverse, so we just need to multiply this A inverse with B. Okay, so write down the A inverse. We just find this value of this A inverse in the matrix form. So 0, 1, minus 2, 9, minus 23, minus 1, 5, minus 13, and just multiply with B, that is 11, minus 5, minus 3. So row with column multiplication, just multiply it. So 1, 2, and 3. So X is equals to 1, Y is equals to 2, and Z equals to 3. Okay, and the remaining sums that in this previous two portions and for this exercise, so you can solve these questions by yourself. They're very easy, and if any problem or any doubt is there, you're free to ask. Thank you.